Okay. So in the last class we talked about permutation, and then we were trying to switch from permutation to combination, and that is where we had things that, I mean, I have no shame in acknowledging that no, I could have done a better job. So let's try breaking it down, because ultimately what we'll understand will be a function of how we are understanding it. Hey Dhanushri. All right. So yeah. So we are just starting, Dhanushri. So in the last pre-calculus class, we talked about permutation, and now we are trying to go from permutation to combination. Okay. And then once we are very clear about these two concepts, then we'll see how do we relate that to deal with probability issues or problems. Now, first thing first, when we talk about permutation and when we talk about combination, what is the main difference? Everybody here?
Permutation is like order matters, and the combination order doesn't matter.
Order doesn't matter. So this is not something that I said. You guys are saying it, okay? So I'll take that as something written in stone. So Dhanushri, what the class is saying is, when you talk about permutation, the order matters. When you talk about combination, order doesn't matter. So if I relate that in simple terms, if I have two things A and B, okay, when I'm talking about permutation, AB and BA are two different things, because the order matters. Which one comes first, which one comes second? The order is mattering to us. But when I'm talking, this is permutation. Yeah? And when I'm talking about combination, AB and BA are not two different things. It's a combination of A and B, that's it. Which one is coming first, which one coming second, doesn't matter. Are you able to relate it now?
Yeah.
Okay. Now, Dhanushri, are you with me, beta?
Yes.
Okay. So now, at least the base, the building block of permutation and combination is clear to us as a group. Now let's go further into it. So, what did we learn in the previous class? When it comes to permutation, let's say if I have, let's say 5 chairs and 5 people to be arranged on those chairs, keeping permutation in mind, meaning who is sitting in the first chair versus who is sitting on the second chair. If that matters to us, that is when it is permutation. And then we can arrange these 5 people on 5 chairs in 5 factorial ways. Yeah? Sure, everybody is sure, right? Everybody is clear? Okay. So, I mean, again, if you want to break it down, first chair you can have 5 options, you will have 5 options. Second chair you will have 4 options. Third chair you will have 3 options. Fourth chair you will have 2 options. Fifth chair you have no other option but 1. And that is how this translates into 5 factorial. Yep. Now I need everybody's attention here. If I had 5 chairs and 3 people to be seated on those 5 chairs. Sorry. If I had 5 people and I had only 3 chairs, if I had to fill the 3 chairs with 5 people, and I'm still talking about permutation, I have not gone to combination yet. So if I had to pick 3, if I had 5 chairs, 5 people and 3 chairs, first chair I could fill in 5 different ways. Second chair I could fill in 4 different ways. Third chair I could fill in 3 different ways. Again, this is permutation. I'm very sensitive about who's sitting on the first chair, who's sitting on the second chair, who's sitting on the third chair. Okay. So, and this translated into a formula that we derived, or if I say 5 options to fill 3 positions, this translates into formula which is 5 factorial divided by 5 minus 3 factorial. Yeah. So again, 5 into 4 into 3, same thing represented in a different way. So it is like 5 into 4 into 3. To complete factorial, I had to put these two here and divide by same number so that I'm not disrupting the the overall idea behind. So this becomes 5 factorial divided by this is 2 factorial, or I can relate this with this 5 minus 3 gives me a 2, so that's what it is. Up to this much is okay, right? Now, so far we are dealing with permutation where the order matters. Who sits on which chair, which position, who takes which position, how they are arranged, jumbled among themselves, that matters. Okay? Now we are going to combination. But let's not go to combination. Now let's look at a situation. I have 3 people, 3 boys, 3 girls, 3 students, whatever you call it, and 2 chairs only. We are having a musical chair competition right now. Okay? So, if I had 3 kids to be seated on 2 chairs, okay? So I will say them as A, B and C. These are three kids. Okay? Now, if I have to make them sit on 2 chairs, how many ways we are talking about? You will say that, okay, don't ask me stupid questions. This is the way for doing it. Okay? Yeah? I am trying to fill 2 chairs with 3 people or 3 kids. And this will give me 3 factorial divided by 3 minus 2 factorial. Yeah? Up to here, okay? This is resulting into 6 options. Now, let's make it even simpler. Now, I had 2 positions to fill by 3 people. So, what are the options I'm talking about? Let's say first position. Let's say this is first position and this is second position, okay? Let's say first position is taken by A. Second position is taken by B. If the first position is taken by A, second position is taken by C. Second position is taken, first position is taken by B. Third position is taken, first position is taken by C. There are 6 options, right? That's what this will give me, right? I'm trying to make 3 kids sit on 2 chairs, and my formula says 6 options. And if I break it down, this is the option that I'm talking about. Yeah? Okay, so this is still permutation because I'm sensitive about who's sitting on the first position, who's sitting on the second position. Now, if I say that I'm immune to this, I don't really care who sits on first position and who sits on second position. Meaning, I'm not interested in how making them sit. What I'm interested in, how do I select group of 2 kids? Let's say, what are the options I had? Let's say I picked A and C, this was my one option. I picked B and C, this was my second option. And I picked A and B, this was my third option. Everybody with me? Dhanushri?
Yes, sir.
Okay. So basically again, I'm repeating the whole thing. I had 2 positions to be filled by 3 kids, A, B and C. So basically 2 seats will be filled by 3 kids. My permutation rule says that if I'm careful, if I'm sensitive about who sits on which position, meaning that when the order matters to me, I'll use the permutation formula and I get this answer. I have 6 options. When I'm just double clicking on that, this is the order that I see. Okay. Now, what I'm saying is, okay, so the 2, if I'm just trying to find out how many groups of kids I can create, what is the combination I can create? If I'm talking about 2 groups, I'm talking about A and C, B and C, and A and B. These are 3 unique combinations that I can create. Is it making sense? Now, if you relate this with what you have here, what is missing? There are 3 options missing. When you are talking about A and C, this is the combination. These are my unique combinations. So combination is nothing but unique combinations. Okay? Without caring about who is coming first, who is coming second. Now, if you relate this with this thing, what you see missing is, so my combination is giving me 3 options, but if I would have gone for permutation, this is combination. If I would have gone for permutation, I would have had this, this, and this. That is how it makes it 6. Meaning, how they are jumbled among themselves. I'm ignoring that part. And when you look at these, every group of 2 kids, I could make 3 unique groups, yeah, by taking it from 3. Every group of kids, I could arrange them, 2 kids within the group, I could arrange them in factorial 2 ways. That's what you are seeing here. They could be arranged among themselves in 2 ways. So, if you look at combination, combination is something where you are dividing the permutation by the number of ways you are arranging, you can arrange them among themselves basically. So, if you got your permutation, meaning if you are careful about the order, you could arrange them in 6 ways. But if you don't care about the order among themselves, you would divide that by the number of people you have in that group. No? Okay. I will probably just derive a conclusion from this one, and we'll extrapolate that to look at a bigger group so that we can relate it. Okay. Now, what we have done so far, we are in a situation where we were trying to find out 2 kids, a combination of 2 kids, or we were trying to fill 2 positions from three options we had. So we were trying to create unique combination of this many, of 2. So when we relate that with the combination, basically combination says, by definition, you are trying to create X number of combinations without worrying about the order among themselves. So whatever comes to us as a permutation where the order matters, if you divide that by the number of ways you can jumble them among themselves, that gives you the unique combination. Hello, Shiv.
Hello, sir.
Okay, so we are talking about combination. So we are just extending that discussion further. Let me put one line of takeaway, that if we are talking about combination, we don't care about the ordering among themselves. So we are trying to create unique groups. That's what is combination. Now, how you derive it? When you can treat permutation as a superset. How many ways you can arrange everything, and then divide that by number of ways you can arrange them among themselves. So divide that by, let's say you had n permutation k, meaning you're trying to fill k position with n resources, and this says you can arrange them in, this formula is factorial n divided by n minus k factorial. This is permutation. Now if I'm trying to find out the unique combination, meaning I'm creating number of groups with each group having this many, meaning I'm trying to form X number of people, I'm trying to fill X number of positions, K number of positions with this many options, or I'm trying to create unique group of K people. Okay. So if I write that as n combination k, meaning from n resources, unique combination of k resources, it will be nothing but whatever is my permutation calculation, I will divide that by the number of ways I can arrange these people among themselves. This is just the formula, okay? This is just the formula that we have interpreted based on what we saw. Now let's look at a little bigger number to deal with so that we can try relating it. Now let's say you had 5 kids and 5 kids, and we had to make them sit on 3 chairs. Okay? We had 5 kids to be seated on 3 chairs. And I'm trying to find out the unique combinations, the number of ways I can select 3 kids out of 5. I'm trying to create unique combination of 3 kids from 5. So that I can say, okay, fine, my first combination will be, let's say, I have A, B, C, D, E. My first combination would be, okay, I will take A, B and C as one combination. My second combination will be, let's say, A, B and D. My third combination would be A, B and E. My fourth combination would be B. I will not say B, A, C. I will say B, D, E. I mean, I have to just be careful that I'm picking 3 kids or a combination of 3 kids which is unique by itself. It doesn't mess with any of them. That's what I'm trying to find out. Okay? So, let's first go to the permutation option. I had 5 kids to be seated on 3 seats. Is everybody able to follow me so far? Dhanushri, safe?
Yes, sir.
Okay. I had 5 kids to be seated on 3 seats. So if I'm just caring about how I'm going to make them sit, I know that my first seat can be filled in 5 ways, second seat could be filled in 4 ways, and third seat could be filled in 3 ways when I'm caring about the order among them. Okay. So, or if you relate that with the formula, it becomes 5 permutation 3, which is obviously factorial 5 factorial divided by 5 minus 3 factorial. Yeah, and this gives me what? This is 5 4 is 20, 3 is 60. There are 60 ways I can make them sit with the order in mind. Now, when I'm talking about combination, I'm saying, okay, fine. For me, A, B, C and B, A, C or C, A, B,
they're all the same.
they are all the same. Even C, B, A. Even B, C, A. Okay? 2 plus 2 plus 1, A, B, C. Even A, C, B. For me, if I look at this as a group or a combination of kids, it's one group. Okay? So, this is one of the group. Let's say ACB, ABC. This transpired into this many. Instead of counting them as 6, I want to count them as 1. And what is this 6? This 6 is nothing but how I am arranging these 3 among themselves. 3 kids, 3 places, factorial 3. That's what is translated into 6. Is everybody with me so far? Yeah? Okay. So let's first look at this. So from 5 I'm trying to find out unique group of 3 kids. So this was 1, A, B, C, A, B, D, A, B, E. Now I'm picking up B, B, let me go this way, B, A, D, B, A, E.
Number 4 is the same as number 2. If
Number
you're doing combinations.
Okay, good catch. So this one is not needed. Okay, good. So ABD, BAD is not needed. BA is there. BAC I cannot go for. I can go for what? I think this is fine. Now I can go to. So this is BAE. Now if I go to C, C, A, B I cannot do, C, A, D I can do, C, A, E I could do. So far it looks okay. Then let's go to E. Sorry, D. D, A, C I cannot do. D, A, B I can do. D, A, B also cannot do.
D A E.
D, D, A, E I could do. Okay. Then D,
There's
B, C. D, B, C I could do. I could do D, B, C. Then let's go to E. That is 9. If I go to E, E, A, B, E, A, E, A, B is there. E, A, C. E, A, C is also there. E, A, D is also there. Then E, C, D.
What about E B D?
Yeah, we'll do that. I'm just checking. E, C, D. Have we done that? E, C, D. No. E, B, D. E, B, D. Yeah. Yeah. I think we covered all the groups.
Yeah.
So, I know this is a very dirty method. And this method is only to kind of convince ourselves that this is how it works. So, if you look at the summary of this, permutation we all learned that okay fine, if I have X options to fill Y positions, it will be X, P, Y, or here 5, P, 3, and that gives me this. But this is, in this case, I am caring about the order among themselves. Now when I talk about combination, this one ABC will be treated unique. But ABC among themselves can be arranged in factorial 3 ways. But when it comes to combination, I don't care about it. So whatever is the value for my permutation, if I divide that by the ways those things can be arranged among themselves, that is what is my combination option. Is it making sense? Save Dhanushri?
Yes, sir.
Then Shiv?
Yes, sir. Yes.
So now let's draw some interpretation from what we have talked so far. The starting point was when we talk about permutation, order matters. When we talk about combination, order doesn't matter. So when we talk about permutation, we are talking about how I'm arranging things among themselves. When I'm talking about combination, I'm just creating X number of unique groups where the order among themselves doesn't matter. So that is why when I'm talking about, let's say, combination of N, C, K, meaning I'm trying to fill K position with N resources, this will be same as the permutation of K from N options divided by the number of ways you can arrange these things among themselves. Because if you don't exclude that, the uniqueness of the combination is compromised. Because like we saw, ABC, CAB, BAC, CBA, BCA, and
CAB. No,
and
sorry.
CAB, and also ACB. These 6 are, it's just the way they are arranged among themselves. So when it comes to combination, that internal arrangement or ordering among themselves doesn't matter. So if you divide by the way you arrange the things among the things within the combination, if you divide the permutation value by the way you are arranging things among themselves, that gives you the combination option. So let's look at one simple example. let's look at one simple example to see how we are able to relate this concept to be able to apply them. Let's look at one problem. I'm reading one problem, and before you guys try solving it, we will just think through it first. Louis is packing a bag for vacation. He has 9 unique shirts, but he can only fit 5 in his bag. How many different groups of 5 shirts can he make? Now, let me read it one more time. Louis is packing a bag for vacation. He has 9 unique shirts, but he can only fit 5 in his bag. So from 9 options, he can pick only 5. So there are different ways he can say, okay, 1, 2, 3, 4, 5, 1, 3, 4, 5, 6, whatever. So he can pick 5 out of 9 in different possible ways. How many different groups of shirts he can take? Now here if you see, he had to pick 5 shirts. We are not really worried about whether he picks 1 first or 2 first or 3 first or 4 first or 5 first. 1, 2, 3, 4, 5. These 5 shirts is one unique combination for him. Which one he is picking first doesn't really matter. So this is a classic example of a combination scenario where you have to you have to pick X number of groups. So you have 9 options. How many ways you can create a group of 5? How many ways you can create group of 5? That's how you look at it. So is this sounding very clear as a combination problem, or there is a doubt about whether it's a permutation or combination? Is it a permutation problem? Is it a combination problem? That is more important.
Combination.
Why? Shiv, can you explain that to me? I'm not trying to put you on the spot. I'm just trying to see if I could reach you well.
Well, combination problem, permutation problem. I mean, one is combination, one is permutation. I mean, combination is like more important because we have to think about how many like different amounts of permutations, because amount of combinations would, so the amount of permutations depends on the amount of combinations.
Okay, let me tell you how would I describe it. My question was, this question was saying that, okay, somebody is packing bag for travel. He has 9 unique shirts. How many ways he can select a group of 5 shirts? Okay. So without me trying to solve this one, first thing that has to be very clear in our mind is it a permutation problem? Is it a combination problem? To me, it's a clearly a combination problem, because in which order that person is picking the shirt doesn't really matter. What matters is what are the shirts that he's picking. Yeah?
Yeah.
And all the shirts are unique, so you don't really have to worry about that part again. So now let's look at another situation. Let's say if I say how many unique words we can make from the English alphabet. So in English we have 26 letters, right? How many 3-letter words we can make? How many unique 3-letter words we can make using the English alphabets? No, so again, I'm not really worried about whether it's coming to be 5 million or 25 million or 296. I'm not really caring about it. I'm saying that, first of all, if somebody says how many unique 3-letter words we can form from English alphabet. We have 26. So what it says is we have to, when I'm saying unique, meaning we are discounting the options of this kind of things. I'm not repeating the letters. Okay? Here I have to treat them as 26 kids filling 3 positions kind of thing. And we are talking about, is this a permutation problem or a combination problem?
Combination. Yeah. Because order matters.
If it order matters, permutation then.
Order doesn't matter. I'm thinking opposite.
No, order matters here. Because is and if these two are legitimate words, they have different meaning. We're talking about different words that you can form. So here it's a classic permutation problem. So that is why, see, again, I'm not really, that's the reason why I'm not really concerned about how much is the answer. What is important for us to understand is, if I have a situation, first thing in our mind we have to be very clear about which way to go. Which one is permutation versus which one is combination. And that we'll be able to derive by thinking about the key concept, right? Permutation, in permutation the order matters. If I'm talking about the words shy and these two are unique words, so the order matters here. The meaning of the word changes. So it's a classic permutation problem. Now once you derive it to whether it's a permutation problem or a combination problem, then it's just a matter of applying the formula. Formula, I mean, you guys can play with that. Is it making sense so far? Dhanushri, Shiv. Now let me give you another example. Let's deliberate this, okay? Now let's say if you are playing cards, okay? Let's say you are the one who is distributing cards and there are five people. How many we have in the class? 2 plus 3, 5, 6. 6 people, okay? So I have a pack of cards and I'm not counting joker, okay? So in the pack of cards, how many cards do we have?
52.
52, right? And interestingly, all the cards are unique because they are belonging to different categories. Any card that you want to recognize, you'll say, okay, it's a spade of A or diamond of A. And spade of A and diamond of A are two different cards. They are unique by itself.
Yeah.
So I have 52 cards. And all of us in the class, we are not trying to learn math, we are trying to play cards on one given day. We want to ditch the plan. Okay? So we are trying to play cards. So somebody is distributing the card. Okay? So you will say that, okay, fine. We want to give 8 cards. 8 cards to each of the player.
Yeah.
Okay? How many unique ways I can distribute the card by giving 8 cards to each people? Is this a permutation problem? Is this a combination problem?
Permutation.
Think about it.
It is like unique ways.
Think about it. Think about it because I will ask you to justify it also.
Justify it.
So here's the question. Again, I'm repeating the question. We have a pack of cards, meaning with discounting the joker, we have total 52 cards, all unique. How many ways I can distribute the card among the 6 players where I have to give 8 cards to each of the player? Is this a permutation problem or a combination problem? And whatever option you come to, you'll have to explain that to me. Yes.
Permutation.
Okay, you say permutation. Let's see. Let's hear the answer first, and then we will beat it to death.
How many players?
6 players. Beat the problem to death. Okay. I mean, you guys are not supposed to misinterpret any of my statement. Okay.
I think it's permutation because like
Permutation.
units.
Okay. Shiv, what do you think? Is it a permutation problem or combination problem? Dhanushri, what do you think?
Can you repeat the question? I think it's permutation, but I'm not sure.
Let me repeat the question and I'll go very slow this time. I have a pack of cards where I'm discounting the jokers. So essentially I'm talking about there are 52 cards. 52 unique cards. I have 6 players. All of us. Shiv, Dhanushri, Biren, Davik, Arush, Sait. So we have 6 players. All of us are playing card in a one class. Okay, no studies. Somebody has to distribute the card. Let's say Dhanushri is distributing the card. How many ways you can distribute 8 cards to each player? My question to you guys is this a permutation problem or a combination problem?
I think it's a combination problem.
Okay, I got one answer is permutation, one answer is combination. I got 2 answers permutation. Okay, what is your opinion?
Permutation.
Permutation. Shiv, tell me what is your opinion?
I think it's combination because it's how many different combinations per person.
I think it's a combination because you don't need a specific order, right?
You don't see. What was the question? In how many ways I can distribute 8 cards to each player? I have, let's say I picked up 8 cards randomly and give it to you. And I'm not talking about in what order I'm giving you those 8 cards. So, only thing I'm trying to do is, I'm trying to identify the ways I can split that into a group of 8.
Yeah.
Only the ways in which I'm trying to create those combination of 8 cards. Combination. It's a combination problem because how you are holding those 8 cards, in what order you are getting the cards, that is none of my business as a distributor. Okay? So, let's look at one more problem. And again, we will not try solving the mathematical part of it. Let's get our head around this one, these type of problems. Okay, that will make it a lot more easier to understand and appreciate. Now, before I move on, so Arush, Sahid, Davik, you guys, I mean, are you guys okay with the argument that I gave, or it is still not convincing enough?
It's good.
Convincing? Okay. Because again, I'll repeat. So I said the question was in how many ways I can distribute the card. So basically the question is in how many ways I can create unique combination of 8 cards. How those are jumbled among themselves, that is not the problem that the distributor is actually wanting to be concerned about. So that's why it is combination. And combination will always be lesser than permutation because it comes by dividing that by number of ways you can arrange them themselves. Yeah? Or if you want to still, like I said, we'll beat this to death. So now let's look at it. Let's take one example. Let's say Shiv got his 8 cards. 1, 2, 3, 4, 5, 6, 7 and 8 cards. Let's say this is a spade. This is 3 diamond. This is 8, let's say heart. Drawing skills, ignore that. Okay. 9, some spade again.
Close.
So, yeah. Then king, let's say heart. Now, when I'm distributing the cards, when I'm giving those 8 cards to Shiv, I'm not really paying any attention to how I'm arranging it. Actually, if you look at it like a game, the person who is distributing the card, actually he's not supposed to look at the cards also. Right? So, for me the order doesn't matter. I'm just trying to see in how many ways I can split it. So, since I'm not seeing the card, I don't know about the order of the card either. For me, what matters is how I'm just creating unique group of 8 cards. That's it. Make sense? Is the problem dead now? Dead? The problem dead. Okay, let's move on. Let's look at one more problem. Simon is creating a flower arrangement. Simon is creating a flower arrangement. A client asked him to select 4 of the 7 available flower options to create the arrangement. How many different group of 4 flowers can Simon choose? Again, let me read one more time. Simon is creating a flower arrangement. A client asked him to select 4 of the 7 available flowers. 4 of the 7 available flowers. A client asks you to select 4 of the 7 available flower options to create the arrangement. How many different groups of 4 flowers can Simon choose? How does it sound like? Permutation problem, combination problem?
Combination.
Shiv, Dhanushri?
I think it's a combination.
Dhanushri, what do you think?
I also think it's
So basically, the question was very explicit. It says, how many different groups of... Here. The question says, how many different groups of 4 flowers can Simon choose? It says, how many different groups? It's, again, group combination. These are like catchy words.
Yeah.
You can relate easily. Yeah. So I agree with you guys. Arush, do you think there could be any element of doubt here with whatever we have discussed? No. Let's pick one more problem. So we are not trying to solve any problem as such. We are trying to break down things into different easier ways to arrive at what kind of problem we are dealing with. Now, here the next question. A club of 9 people. Oh, this one we talked about in the last class, I think. Did we? Okay, let me read it. A club of 9 people wants to choose a board of 3 different presidents. One second, let me make it bigger. A club of 9 people wants to choose a board of three officers. President, Vice President and Secretary. How many ways are there to choose the board from the 9 people? Let me read it one last time. A club of 9 people wants to choose a board of 3 officers. From 9 people want to choose 3 officers. President, Vice President and Secretary. They are the 3 officers. How many ways are there to choose the board from 3 people? Is this a permutation problem or a combination problem? Yes, Shiv.
It's a permutation problem because now it doesn't matter about the order because a person could be vice president or president. So it can be switched around, being vice president or president or whatever. So it can be switched around, so it should be a permutation.
So you are contradicting yourself. Think about it and then tell me. You said the order doesn't matter and then you said it's a permutation problem. And that's one thing I want to clear our minds, that when the order doesn't matter, it's combination. So you have to tell me whether the order matters or not, and based on that you can tell me whether it's a permutation or combination. Let me read the question one more time because I have been selling this concept really hard. That's why I'm not even doing Nike right now. I'm only focusing on these 2. And I don't get royalty for selling this because this is my own product. Nobody pays me for this, but I'm just selling that to you guys. Let me read one last time. A club of 9 people want to choose a board of 3 officers. President, Vice President and Secretary. How many ways are there to choose the board from the 9 people? Is this a permutation problem or is this a combination problem? And first tell me the answer, then I'll ask you why. Don't tell the why part now, just tell me the answer for now. Now Shiv, what do you think?
Yeah, I think it's combination.
Okay, it's see again, I did not say that what you said the answer was wrong or not. What I contested you for, what I argued was for the contradictory statement, permutation and combination, permutation and order not mattering. That was my argument for. So I'll take your point as combination, yes.
I think it's permutation.
Okay, you think it's permutation. Dhanushri, now we have enough food for thought to get confused. We have to put the options alive still.
I think it's wait. So they're asking for a specific. Okay, can you repeat the question again?
Okay, yeah. A club of 9 people want to choose a board of 3 officers: president, vice president, and secretary. How many ways are there to choose the board from the 9 people?
It's permutation.
I think it's combination because it didn't say they have to specifically choose it president, vice president, and secretary. You can choose it either way, but I don't know.
Okay.
It's a bit confusing. I'm gonna go with combination.
Okay.
I think it's permutation because like if you're asking like which one you have to choose, it has to be like in a specific like order, like president, vice president, and secretary. So it's supposed to be permutation.
Is that your argument too? How about yours? See, in this kind of situation, right? I mean, this is a real life situation where you will have a question. There will be a very thin line between the selection. Let's read. This is where this will come to our rescue. Let's read one more time, and then we will deliberate this. A club of 9 people want to choose a board of 3 officers: president, vice president, secretary. So far, it has not told me any order. Says the board wants to choose 3 officers, 3 roles. How many ways are there to choose the board from 9 people? How many ways are there to choose the board from 9 people? So essentially, they are trying to select 3 people, group of 3 people.
I mean, it's not necessarily a group of 3 people because they're saying how many ways, and it's like saying you can have say it's A, B, and C as president and vice president and I forgot what the last one was, but like if you say A, B, and C as president, that's one way, but then saying C, B, and A would be a different one.
But now look at it from the group's perspective. Okay? Let's say David got selected as president, Dhanushri as vice president. So this is president, vice president, and secretary. Let's say who wants to be secretary? Let's say Sahit became the secretary. Whether it's David, Dhanushri, or Sahit Dhanushri and Davik, or Sahit, Davik and Dhanushri, this is still one group. This is just one way to select these 3 officers. Because the board would not care. I mean, the society or whatever it is would not care who's president, who's vice president versus who's secretary. And if they care, they will say, the question will say it loud and clear. Here in this question, again, this is my argument. I'm not saying that my argument is right. But what I'm saying is, even if I read this question one more time to convince myself why I'm thinking that way, a club of 9 people wants to choose a board of 3 officers. Fine, president, vice president, secretary. How many ways are there to choose the board from 9 people? How many ways? How many unique combinations? How many possibilities are they talking about? Because now if they say how many ways, you guys are making me think actually. Okay. How many ways? Let's forget about permutation, combination, everything. Let's look at these 3 positions as 3 chairs. This is the president's chair, this is the vice president's chair, and this is the secretary's chair. It is not saying how many unique combinations either. So I'm kind of thinking against my own thought. How many ways these positions can be filled? I had 9 options. First one could be filled in 9 ways. After that, one person, whoever was selected, is gone. Then we had 8 options to choose the second position. After these 2 positions were filled, the third position could be filled in 7 different ways. So, while my initial thought was that this is a combination problem, but for combination, it did not give me that catchy word, group, unique. Okay? And when I'm thinking about it again, it says how many ways I can select. So it's like filling 3 positions with this many people. So here, how many ways the first position is getting filled, it matters, right? I mean, we have 9 options. So here, even if it is not explicitly said that the order doesn't matter, but actually it's mattering here. So that's the reason why I'm leaning towards permutation now. What I'll do is I'll check the answer for this one in the book also where I referred to this one. But conceptually, if I look at it, I see this be as a permutation problem. Do you guys think that it's okay to tolerate the teacher when the teacher contradicts himself within 10 minutes? Shiv, what do you think?
Yeah.
Does it make sense? I'm kind of breaking it down. I'm making it even more simplistic to look at it. But okay, forget about permutation combination for a little bit. 3 chairs to be filled. First chair. How many ways I had?
None.
Okay, one position gone. How many ways I had? 8.
8.
Established.
That's the number of ways. I would probably not overthink about it. I'll keep it simple. So any problem that you deal with relating to permutation, combination or probability, always try breaking it down. So you might get, I mean, the good thing is if the person who has set the question has thought about it like a permutation problem, then the answer, one of the answer will match. If the person has thought about it like a combination problem, then if the person is trying to confuse you, then you'll have 2 options. That is where you have to make the judgment based on how you kind of decipher it from understanding point of view. Is it making sense? So what I would request this time is try doing the unit test for this one, okay? Because permutation combination is an interesting topic, quite relatable topic. So go to Khan Academy, try doing a unit test and see if you are able to relate the concepts, right? How do you break it down? Let's pick another problem and see if the confusion prevails. Let's look at one more problem. Neha is playing a word game where she is trying to make 3-letter words.
Is it permutation?
Let me complete.
It's reversible word.
Okay, no. I mean, see, I'm not discouraging you from being faster than me. What I'm saying is, I have a very compulsive reason for sticking to this. Okay, and I would want to prescribe that. Let me read this. Neha is playing a word game where she is trying to make 3-letter words using letters in the word tiger. The word is tiger. Using the letters in this word, she is trying to make 3-letter word. She cannot use the same letter twice. So no option to repeat. How many unique ways are there to arrange 3 letters from the word tiger? So now, to Arus's point, Arus was very quick in making a judgment that this is a permutation problem. And I have no ways to deny that. When we're talking about word problem, order matters. ABD and BAD will have 2 different meanings. I don't know if this is a legitimate word or not, but assuming this is. The order matters. So any word problem, anything that is talking about the unique words and all, that gives the first clue that this is a potentially a permutation problem. So if I read one last time, Neha is playing a word game where she is trying to make 3-letter words using letter in the word tiger. She cannot use the same letter twice. How many unique ways are there to arrange 3 letters from the word tiger? So is this sounding like a permutation problem or a combination problem? I have one answer already, which is a permutation.
I agree with that.
Okay, copy paste. Dhanushri and Shiv, do you guys think it's a permutation problem or a combination problem?
I think it's a combination problem.
One more time, Virat.
I think it's combination.
Combination problem? No, let me read it. So again, I'll repeat myself. When you say combination, the order doesn't matter. Right?
Oh wait, no, it's 987. So it should be permutation as you multiply, right? Because it will be factorial.
No. So my question was this, Vita, that if I'm talking about, there are two scenarios, permutation and combination. When I'm talking about permutation, order matters. Which one coming first? ABD, BAD, DAB, these are different things for me. If I'm talking about permutation, the order matters. If I say that, okay, these 3 are same for me, then it is combination. Basically, I have taken a group of A, B and D and I am saying, okay, don't worry about it, I will figure out how do I jumble them up. Yeah? So, if I read the question one last time, what it says is, somebody is playing a word game. So, how you are arranging the alphabets, that is going to matter, the meaning would change. She is trying to make a 3-letter word. She is trying to make 3-letter words using the letters in the word tiger. So there are 5 letters here and nothing is repeated. All are unique. So from 5 unique things you are trying to create a group of 3 where the order matters. And if the order matters, it's a permutation problem. Dhanushri, do you agree or you don't?
I agree.
Okay.
Permutation problem.
Yeah. So if today I literally wasted 1 hour of your time without solving even one problem. So let's just for the sake of compliance, let's solve this problem.
Okay.
So we have a word tiger and Neha was playing a word game. She was trying to make 3-letter words from this word tiger and the condition was that none of the letters should be repeated. So I cannot have I and I as one word. Okay? So essentially these are like you cannot make one person sit on 5 chairs, same way you cannot use one letter in 5 positions or 3 positions here. So we are trying to create 3-letter word. It's a permutation problem from the 5 options we have. So it will be factorial 5 divided by 5 minus 3 factorial. I keep using factorial 5 factorial interchangeably, but anyways. So if I do that, it becomes factorial 5 factorial divided 5 minus 3, 2 factorial, which is 5 into 4 into 3 into 2 into 1 divided by 2 into 1, do tic-tac-toe, 5 4 the 20, 3 the 60. This many words you can make. Yeah.
Like, what if it's like not a word?
I'm sorry?
Like, what if it's not a word? Because out of tiger, you can make something like REG, but REG is not a word.
So that is, so we are not being tested for the vocab here. It says how many unique words you can make. So assuming that anything that is made which is not repeating the letters is a legitimate word. So I mean they will figure it out. But I mean we don't really have to worry about whether the word that is getting formed is legitimate or not, because that is out of the purview of the question. Okay, you are raising your hand. Yeah, tell me.
I was about to say the
Same thing? Yeah. So that is we are looking at this problem as a mathematical problem, not as an English problem, because we don't have the ability to memorize everything from Oxford point of view, and this probability question is not requiring us to have that either. Now let me flip. I was solving this for a reason. This question has a statement saying that if the letters are not supposed to be repeated. Okay? If you are allowed to repeat the letters, then how many words you can form?
You can form an infinite amount of like
Don't rush. Think about it. Did you guys get my question? A tweaked question actually. This question was saying that I have 5 letters from which she has to make a 3-letter words, where the condition is she is not supposed to repeat any of the letters in the word. So she cannot have E and E in the as a word. Now I'm saying, okay, I'm deleting that condition completely. How many 3-letter words she can make when she is given the full freedom of doing whatever she wants to do within the boundary of these 5 characters?
A lot.
That will not solve the purpose. You guys are overthinking. Okay? Let me simplify this. Think like a baby here. My 3-letter word will be made by filling these 3 positions, 3 boxes, correct? When I'm trying to fill the first box, how many ways I can fill it? 5?
Yeah.
When I'm filling the second box, how many ways I can fill the second box?
4.
5. Because the condition is taken out.
Oh yeah. So then you just do 5 again. So it's 5.
5 times 5 times 5, that's it. Think like a baby, that's what I'm saying. Because babies are not only intelligent, they don't overthink. Yeah? Makes sense? I mean, is it making sense to everybody? And this is a very common situation that you might come across. So that's why permutation combination, if you look at this is a concept. This is just a concept that augments the understanding. Your basic will remain in place. How you visualize it, think it in a broken down way. And then you see where you want to apply the formula. That's it. Okay? So don't start your permutation combination problem with the formula in mind. Break it down first, think about it, visualize it, make a dirty looking note. Okay, this is what I'm talking about. I have all the reasons to bother you guys, okay? Read, then do the scratch work before you do it, because you have enough tools and ammunition in your pocket which you can use any time. But these two have to be emphasized more. Is it making sense, everybody? Dhanushri, Shiv? Yeah?
Yes, sir.
So how many times you have heard this from me, Dhanushri, by now? Probably 100 times. Sorry for annoying you guys so much, sir, but yeah, I mean, I'm very clear about it, okay? Because most of the times, when we do a thoughtful evaluation of what we are trying to achieve, our job becomes easier. And trust me, math, you'll have to find out easier thing in the solution actually. If you overthink about it, it might bother you more than you would want it to. Yeah? Alright? With that being said, I'll let you guys go, otherwise you will keep on hearing my emotional speech and that will bother. Alright? Talk to you guys tomorrow, yeah? We are meeting tomorrow again. You are having overdose of me, but only for this week. Next week we'll go back to our normal schedule where we'll meet on Saturday, Sunday and then on Wednesdays. Yep? Alright?
Sir, thank you.
Bye bye, take care.
Bye, sir. Thank
Bye bye.
you, sir.
Bye bye, Beta.
Bye, sir.
Bye bye.